Hello, welcome back. This video is a series, and if you haven't watched the first part of this video titled The Mole, I would advise you pause this one and watch that part because it's introductory part to this video. Okay? Today our discussion is The Mole 2. I titled this The Mole 2, continuation of the first one titled The Mole. Last time, we talked about the concept of the mole, what mole means. Just like dozen, we said that one mole contains 6.02 times 10 to the power 23 particles of any substance. Just like dozen contains 12 pieces of any substance. So today, we're going to talk about the relationship between mole and mass. I would also like to remind you the concept we discussed some time ago about the meaning of molar mass. Molar mass simply means mass of one mole. Mass of one mole. And it is relative atomic mass or molecular mass expressed in grams. So when we say molar mass, for instance, molar mass of carbon is 12 grams per mole. Because 1 mole of carbon atoms weighs 12 grams. Okay? Good. So if you look at this diagram, this is 1 mole of carbon. 1 mole of carbon atoms. And it weighs 12 grams. So this is the molar mass of carbon. And remember that 1 mole of any substance contains 6.02 times 10 to the power 23 particles of that substance. Therefore, 1 mole of carbon contains 6.02 times 10 to the power 23 atoms of carbon and also weighs 12 grams. 12 grams. 1 mole of water molecule weighs 18 grams because the molar mass of water is 18 grams per mole. So 1 mole of water molecule weighs 18 grams. And inside that 1 mole, we have 6.02 times 10 to the power 23 molecules of water. So if you look at this, 1 mole of a substance contains 6.02 times 10 to the power 23 particles of that substance and weighs the molar mass. So this implies that 1 mole of carbon contains 6.02 times 10 to the power 23 atoms of carbon and weighs 12 grams. 1 mole of water contains the same number of particles and weighs 18 grams. While 1 mole of sodium hydroxide contains the same number of molecules but weighs 40 grams because the molar mass of sodium hydroxide is 40 grams while the molar mass of water is 18 grams and the molar mass of carbon is 12 grams per mole. Okay? So having known this now, when you see something like this, the formula of any compound, when it is written, the number of mole is written in front. For instance, this is sodium hydroxide molecule and we have 2 in front. This means 2 moles of sodium hydroxide. This is water molecule and there is nothing in front. It means 1 mole because this is 1 mole of water molecule. This is carbon and we have 3 in front. So this is 3 moles of carbon atom. So if you see something like this, you should know what you have to know what it means before you start solving problems. So let's solve some problems on this. What is the mass of 2 moles of nitrogen gas? What is the mass of 2 moles of nitrogen gas? That's the first question. First of all, what is the formula of nitrogen gas? Nitrogen exists as the atomic molecule in nature. So nitrogen gas is N2, not just N. Okay? So first of all, what you have to find out is the molar mass of nitrogen gas. Nitrogen from here has the atomic mass of 14, right? But nitrogen gas, which is the molecule, is diatomic. So we have 2 times 14, which will give you 28. So the molar mass of nitrogen gas is 28 grams per mole. Are you getting it? Now that we have the molar mass of nitrogen gas, what it means is that 1 mole of nitrogen gas weighs 28 grams. Are you getting it? And the question says, what is the mass of 2 moles? So if 1 mole of nitrogen gas weighs 28 grams, then 2 moles will weigh Z. Assuming Z is the unknown, okay? Is the mass we are looking for. If you cross multiply, you will have Z equals to 2 times 8. I mean Z. Z equals to 2 times 28, which will give you 56 grams. Are you getting it? Therefore, the mass of 2 moles of nitrogen gas is 56 grams. This is a mistake. 56 grams. Okay? The second question says, how many molecules are these 2 moles, are in the 2 moles above? Now that we know that 56 grams is the mass of the 2 moles, how many molecules are in those 56 grams? So what you do is, first of all, you know that 1 mole of nitrogen gas, as well as 1 mole of any other substance, contains 6.02 times 10 raised to the power 23 particles of that substance. That means 2 moles now will contain how many molecules? Let's say the molecule we are looking for is Y. How do we find Y? We cross multiply. So we have Y equals to 2 times this, which will give you 12.4 times 10 raised to the power 23 molecules. So 2 moles of nitrogen gas will contain 12.4 times 10 raised to the power 23 molecules. Do you understand? You can as well use the formula method to solve this problem. Alternatively, solving the first question, we can use this formula. N equals to W over M. I hope you still remember this formula from the last video. N here, the small letter n is the amount, which is number of moles. While W here is the mass of the substance we are looking for, or the mass of the substance given. I use W. Some textbooks use small letter m, but to avoid confusion, I use W to represent the mass. While capital M is the molar mass of the substance in question. So from the question, what is the mass of 2 moles of nitrogen? We have that the number of moles given is 2 moles. So N is 2. While the molar mass of nitrogen from our calculation is 28 grams. Then the question is, what is the mass of those 2 moles? So W is what? That's what we are looking for. So from this formula, make W the subject of formula. So cross multiply, you have W equals to NM. So N is 2 and N is 28. So you have 2 times 28, which will give you 56 grams. So 2 moles of nitrogen has a mass of 56 grams. Okay. Then the second question can also be solved using formula. This formula, N equals to capital N over L. Small letter n remains number of moles. Capital N is the number of particles we are looking for, whether the particle is atom or molecule. N represents the particle in question. Then L represents the Avogadro's number, which is constant, 6.02 times 10 raised to the power 23. So the question says, how many molecules are in the 2 moles above? So molecules is what we are looking for. That means particles. N, we are looking for N. So from this formula, making capital N the subject of formula, you have capital N equals to small n amount times L. So we have 2 from here times 6.02 times 10 raised to the power 23, which will give you this. Therefore, 2 moles of nitrogen will contain this. Okay? You can also use this formula method if you choose. Then, let's solve one more question on this. What is the number of molecules in 6.4 gram of sulfur 4 oxide? Given that sulfur, atomic mass of sulfur is 32, oxygen is 16, Avogadro's constant is this. The second question says, how many moles is this sulfur 4 oxide about? The first question, we are looking for the number of molecules in 6.4. So let's write out the parameters. The molar mass of sulfur 4 oxide, remember sulfur 4 oxide is SO2. So to get the molar mass, you calculate that. Remember, I hope you can still remember this. You get 64 grams. So the molar mass of sulfur 4 oxide is 64 grams. So sulfur 4 oxide, 64 grams, is the mass of 1 mole. So 64 grams of sulfur 4 oxide contains 6.02 times 10 to the power 23 particles. Okay? Molecules of sulfur 4 oxide. Because that's the mass of 1 mole. The question says 6.4 grams will contain how many molecules? So let the molecule be Z. So to find Z, cross multiply, you have Z equals to 6.4 times 6.02 times 10 to the power 23. Then divided by 64, which will give you 6.02 times 10 to the power 22 molecules. So Z is equals to this. Then the second question says, how many moles is in this sulfur 4 oxide? I like using proportional method, so pardon me. Since we know that 1 mole of sulfur 4 oxide contains 6.02 times 10 to the power 23, we are looking for how many moles that are in this 6.4. So, Y moles will be in 6.02 times 10 to the power 22. Because this 64 gram contains 6.02 times 10 to the power 22 molecules. So, how many moles will be in this number of particles? So, if you cross multiply, you find out that Y is 0.1 because you have 1 times this divided by 6.02 times 10 to the power 23, which will give you 0.1 mole. So, therefore, 64 grams of sulfur 4 oxide is 0.1 mole, and it contains 6.02 times 10 to the power 22 molecules. I hope you understand. You can still use the formula method and solve the problem. Okay? Then, I believe with this you can solve this study question. I would like you to pause this video and try your hands on this study question. Then ask me your question if you have any. Thank you for listening. Bye!